In this problem, A and B are both quoted in prime numbers raised to different powers. Now, in a way, they've factorised this thing for us. Just in case this looks a little bit daunting, it isn't really. I've written those out as sort of reference. So if we just look at the 2's, yes, we've got a pair there, and we've got a pair there. So from 2 to the 4th, which is part of A, and 2 squared, which is part of B, all we've got to do is subtract the numbers. 4 minus 2 gives us 2 squared, which is 2 times 2. And these yellow grouped common factors are what we're looking for when we're finding the HCF. So I can say that the HCF of A and B is equal to 4 2's take away 2 2's is simply 2 squared. The common number of 3's is 3 squared. And we've got no other common factors because the rest of A is multiplied by 7 3 times and the rest of B is multiplied by 5 twice. So this is equal to 4 multiplied by 9. So this is equal to 36. And that is the answer to part A. So let's have a look at part B. So the LCM is equal to the HCF multiplied by the other factors. So let's call them Y. So we need to work out what remains from the other factors that we've not made common in the HCF. So I've got the LCM is equal to the HCF, which we know is 36, multiplied by, well, let's have a look at the 2's. Well, 2 squared is common, but in A terms, we've got a still a multiply by 2, multiply by 2. So this is multiplied by 2 squared. In terms of the 3's, 3 squared is common, but 3 to the power 3 remains unaccounted for. So this is multiplied by 3 to the 3. And as 7 cubed and 5 squared found no partners, we must write them down as just a copy and paste. So this is 7 to the power 3 multiplied by 5 squared. Remember that HCF here is equal to 36. And if you pop it into a calculator or do it by hand, the answer you should get is 33,339,600. And that is your answer.